Under a stormy sky over contested terrain, a variable geometry wing jet streaks low, its twin engines roaring as wings sweep back for high-speed penetration. The Sukhoi Su-24, NATO reporting name, Fencer, is a supersonic, all-weather tactical bomber developed by the Soviet Union for deep-interdiction and ground attack missions. Designed as a direct counterpart to the American F-111 aardvark, the Su-24 was created to deliver conventional and nuclear ordnance against heavily defended targets. In adverse conditions, the requirements stemmed from the need for low-level, high-speed penetration capabilities amid advancing NATO air defenses during the Cold War. In modern air warfare, the Su-24 remains relevant for nations employing standoff precision strikes and terrain masking tactics, particularly in asymmetric conflicts. Origin and development history: the Su-24 originated in the Soviet Union. Designed by the Sukhoi Design Bureau. Primary manufacturers were the Novosibirsk Aircraft Production Association and other facilities. The program began in the mid-1960s, with the first prototype flight on the 17th of January 1970 variable geometry version. It achieved operational service in 1974-1975. The aircraft was developed to provide a supersonic, all-weather interdictor capable of replacing older platforms like the Yak-28 Brewer and Il-28 Beagle. It directly responded to the US F-111, incorporating variable sweep wings for enhanced low-level performance and payload. Design philosophy and airframe: the Su-24's design philosophy emphasized low-level penetration, all-weather capability, and ruggedness for operations from forward bases. Its airframe features variable geometry wings sweep from 16 to 69, mounted high on a slab-sided fuselage, with side-by-side seating for the two crew members to improve coordination. Primarily constructed from aluminum alloys, with no significant composites or stealth coatings. Aerodynamic choices include large rectangular side intakes, leading edge slats, and double-slotted flaps for stable low-altitude flight and short takeoff, landing. Visually and technically distinctive are the variable sweep wings, boxy fuselage earning the nickname suitcase, and side-by-side cockpit unique among Soviet strike aircraft. Engine and propulsion system: the Su-24 is powered by two Saturn Lyulka AL-1 F3A afterburning turbojet engines, each producing 75 kilonewtons, 17,000 pound dry thrust, and 109.8 kilonewtons, 24,700 pound with afterburner. Thrust-to-weight ratio approaches 0.7 in typical configurations, enabling effective low-level dashes. The engines provide strong acceleration for evasion, but contribute to high fuel consumption during afterburner use, impacting maneuverability in prolonged engagements, speed and flight performance. Maximum speed is Mach 1.6, approximately 1,900 km per hour or 1,180 miles per hour at altitude. Mach 1.6, 1,315 km per hour or 817 miles per hour at sea level for later variants. Early models reached Mach 2.18 before intake modifications. Cruise speed is subsonic, typically around 900 km per hour. Service ceiling is 11,000 to 17,000 meters, 36,000 to 55,755 feet, varying by variant, and load lower for operational low-level profiles. Rate of climb exceeds 100 meters per second in clean configuration. Maneuverability is optimized for stability at low altitudes with high wing loading, allowing gust-resistant terrain following flight, though not suited for dogfighting. Range, endurance and fuel combat radius is approximately 560 to 650 kilometers, 350 to 400 miles, without external tanks. On typical missions, ferry range reaches 2,775 to 3,000 kilometers, 1,724 to 1,864 miles, with drop tanks. Internal fuel capacity is around 11,100 to 12,000 liters. External fuel tanks are carried on underwing and glove pylons. Later variants include aerial refueling probes for extended endurance. Fuel consumption and operating cost public estimates indicate fuel burn rates of 5,000 to 7,000 kilograms per fly hour. In operational profiles, higher with afterburner, historical flyaway costs were approximately $24 to $25 million in the 1990s. Operating the Su-24 is expensive due to twin turbojet maintenance, high fuel demands, and complex variable geometry systems. Logistics are challenging for aging fleets, requiring extensive inspections and specialized spares. Avionics and sensor systems. Early variants used mechanical scan radars like Orion for attack and rely for terrain following. Later Su-24M featured improved PNS-2 for navigation and Kara-24 laser TV designator. Upgraded Su-24M incorporates SV-P20 for specialized computing subsystem for enhanced precision without full sensor fusion. Electronic warfare includes radar warning receivers, jammers, and chaff flare dispensers. These systems improve situational awareness in low-level flight and reduce pilot workload. Through integrated navigation and targeting, weapons and payload air-to-air missiles include a 60 AA-8 Aphid and later a 73 AA-11 Archer for self-defense, up to for carried. Air-to-ground options encompass unguided bombs, rockets, KH-23 29, 31 58s, 59 series missiles, and precision-guided munitions like KAB-500 1500s on upgraded variants. Weapons are externally carried on 8 or 9 hardpoints, no internal bay except fixed GSH-6-3. 23mm cannon with 500 rounds. This configuration supports flexible missions from close support to anti-ship strikes, stealth and survivability if applicable. The Su-24 has a conventional radar cross-section with no dedicated stealth shaping or coatings. Infrared and electronic signature management is limited to basic exhaust shrouding and countermeasures. Defensive systems include radar warning, active jammers, and chaff flare dispensers. Strengths lie in low-level terrain masking and speed for evasion. Limitations include vulnerability to modern air defenses without standoff weapons or escorts, real-world service and combat use. Current operators as of late 2025 include Russia, approximately 260 to 290 aircraft across aerospace forces and naval aviation. Ukraine limited numbers, round 10 to 15 Su-24M, Mr. Algeria, Iran, and Syria. Combat includes Soviet-Afghan War, Chechen conflicts, Syrian civil war, Russian and Syrian operations, and ongoing Russia-Ukraine war both sides, including Ukrainian Storm Shadow launches. Performance has been reliable in low-level strikes, though losses highlight vulnerabilities. Evaluations note effective penetration, but high maintenance demands. Cost, production and global impact. Unit flyaway cost was around $24 to $25 million in the late 1990s, adjusted equivalents higher today. Total production exceeded 1,400 aircraft from 1967 to 1993. Exports went to allied nations, with some restrictions post-Cold War. The Su-24 influenced tactical aviation doctrines, providing affordable deep strike capability and shaping regional balances in Middle East and post-Soviet conflicts. Strengths and weaknesses. The Su-24 excels in low-level, all-weather strikes. Robust payload, range for its era, and proven reliability in harsh environments. It is limited by aging turbojets, high consumption, lack of stealth, and vulnerability in contested airspace. Criticisms include maintenance intensity and obsolescence against integrated defenses. No aircraft achieves perfection. The Su-24 for balanced speed, payload, and cost-effectively for tactical bombing. Final verdict. The Sukhoi Su-24 Fencer represents a cornerstone of Soviet tactical aviation history, embodying variable geometry innovation for Cold War-era penetration missions. In modern and future warfare, its role persists through upgrades for precision strikes, as seen in ongoing conflicts, respected by allies for durability and by rivals for battlefield effectiveness. The Fencer endures as a pragmatic symbol of all-weather strike power,